This is Professor Elliott again, and today we are going to look at using rheostats in series DC circuits. So here's our basic series circuit, and we're going to solve it the same way as any other circuit. The only difference is we have to take into account the impact of the rheostat, which will affect the resistance and the current. And so anyway, okay, so for this exercise I've positioned the wiper so that it's 80% up from the bottom terminal here, and I hope it's clear that there's 20% remaining. So of the resistive element on which the wiper slides as we turn the adjustment screw, 80% of it is shorted. So if we use conventional flow, so current would come down like that, like this, go around like this, and down. So effectively, R2 has a value equal to 20% of the 2000 ohms. So R2, the actual or effective, is going to be 2k ohms times 0.2, which means that we have 400 ohms, and we can say that RT, which is simply R1 plus R2, equals the 500 plus the 400, gives us 900 ohms. Okay, so it's a series circuit, so like any other series, the current is the same at all points. So that equals E divided by RT. So that equals 40 divided by 900. And so we got 40 divided by 900, which is 0.9. Over to kiloohms. So we get milliamps at 44.4444 milliamps, and V1, Ohm's law, I1 times R1, so it's 44.4444 times 0.5 gives us 22.222 volts. Put a line, and then V2 equals I2 times R2, so it's the 44.444 milliamps times the 400, not the 2000, okay, equals 17.7778 volts, and V1 plus V2 equals E there could be a very slight rounding, but I get 39.99999, which is perfect. This equals 40 volts. Alright, so I'm not going to bother with the powers. If you want to calculate it, go ahead and do so. You have all the information. But there we go. Okay, so we just simply move the wiper to a different position. So now 80% is available. So for the current, I think we're using conventional current. Yes. So it's going to go like this, and then around like this. So here it's 20% shorted. Let me just go back. Right? So we have over here, we have 80% shorted, 20% available. Look at the, here we have 80% available, 20% shorted, because we just moved the wiper to a different position. Okay, so the actual or effective value of R2 is now the nominal or maximum value of R2, which is 2K, times 0.8. So it's 2 times 0.8 equals 1.6 K ohms. And now we can find everything again. Okay, RT equals R1 plus R2. That's going to be the 500 ohms, 0.5 K plus 1.6 equals 2.1 K ohms. And IT, which is I1 I2 equals E RT 40 divided by answer equals 19.0476 milliamps. Of course, the current changed because RT changed because we moved the wiper. Okay. Okay. V1 equals I1 times R1, so it's times 0.5, 9.5238 volts, and V2 equals I2 times R2, so that's 19.0476 times 1.6 K equals 30.4761 volts. And it looks good. Let's just make sure. Add the two together, and I get 39.999996, which equals 40 volts. Okay, so in the rheostat, we have adjustable resistance, and by changing the resistance, we change the current, we change the voltages. Does that make sense? Great. Okay, let's go on. So let's take the same device and jumper the wiper to the other pin. Okay, oops. Yeah, slide. Sorry about that. Okay. So we're not going to do the whole thing, but here's basically what we got. Okay, so we had a battery, right? Then we had R1, and then we had R2. Right, this was R1, and this was R2. Okay, so just continuing with the last example. So the last example we had, go back, see where the wiper is. Okay, we had 80% down from the top. Okay, so we're going to have like this, alright. So all I've done, I want to change the color, let's go to black, is instead of jumpering it to this pin down there, right, we've jumpered it up up there. Okay, but we left the wiper in the same position. So now we have 80% of it is shorted or bypassed by the jumper, and we have 20% unbypassed. So that would mean that the actual effective value of R2 equals 2k ohms times 0.2, right? So that would be 2 times 0.2, that's back to our 400. Okay, now in the lab, it doesn't make any difference which way you jumper it. All that means is if you jumper it one way, if you turn the screw clockwise, the resistance will go up. If you jumper it the other way, if you turn it counterclockwise, the resistance will go up. In the test, however, in any quizzes, pay close attention to which way we've jumpered it, because if you interpret it incorrectly, you will change your result. Okay, so in actual practice, it doesn't matter, but in terms of our calculations, yes, it does matter which way it's jumpered. So just don't memorize what we did last time or in class. Look at what you have in front of you and just solve it based on that. Fair enough? Wonderful. Next. Okay, now let's take the potentiometer, which we previously reconfigured as a rheostat, and we're going to use it as a potentiometer. Potentiometer means variable or adjustable voltage. Okay, this could do one problem here. So everything's the same. Notice there's no jumper here, and for our purposes, we're just going to connect a voltmeter from point X down to the ground. So we're really measuring the voltage between this point here and this point here. In practice, this would go into an electronic circuit, but that's beyond what we want to cover in this course. So let's just assume that our wiper here is down 15%. So that means then this span here must be 100 minus 15, which is 85%. Okay. Unlike the rheostat, wherein the resistance changes as you move the wiper, the resistance here is absolutely constant. So it makes no difference where you position the wiper on the potentiometer, because the resistance doesn't change. What does change, however, is the amount of potential between the wiper and the ground. So this is Vx, what we're measuring. So if you moved the wiper up to point A, then the voltage would be at a maximum value of Vx. Okay. If you move the wiper all the way down to, these are just arbitrary points, point B, then this would be a minimum Vx. And of course, would in this case, in fact, equal to 0. So we're going to calculate what is Vx with the wiper position as shown, 15% down from A or 85% up from B. It's the same point. Okay, so that means then that current IT equals I1 equals I2 equals E divided by RT, and that equals 40 volts divided by the 500 plus the 2000, 2 2.5K, so that's 40 divided by 2.5 gives us 16 milliamps. And then, so then what we can do, we want to figure out what the voltage is across Vx, so from this point to this point. Okay, so we can say then that voltage Vx equals the nominal resistance of R2, so that would be 2 k ohms times (16 milliamps). Okay, so that will give us the voltage across the whole R2. That's from that point all the way down to that point. But from the wiper to point B, the ground, we only see 85% of that. So we have to multiply that by 0.85. All right, hopefully you're with me. 2 times 16 times 0.85 equals 27.2 volts. And I think I need one more page. So go back. So therefore, the voltage from point A to the wiper, which is the remaining 15%, so voltage between wiper and point A equals R2 times IT times the 15%. So that's be the voltage across the remaining 50% of the wiper. Okay, I gotta go back. So that's going to be 2 times 16, which is 32 volts, times 0.15 would be 4.8 volts. Okay, and so that's going to be the voltage right between these 2 points. Okay, and then finally V1 will be I1 times R1. So that will be the 16 milliamps times the 500 ohms equals 8 volts. So therefore, we can finally say that E will be V1 plus the voltage from the wiper to point A, so plus 4.8 plus Vx 27.2 So we have 27.2 plus 4.8 plus 8 equals 40 volts. Okay, So all I've really done is just one different color, green, is I've just taken what's the voltage across here, added to the voltage here, added to the voltage here, which is Vx, to make sure we get back into 40 volts. Okay, so we got everything. Yeah. All right, so I hope that makes some sense, and thanks for listening. Bye.